it is given to us that if cos alpha plus cos beta plus cos gamma is equal to sin alpha plus sin beta plus sin gamma, which are also further equal to 0, then we have to prove all these four results. So for that, let's recall the de Moivre's theorem. If n is any integer, then cos theta plus iota sin theta to the power n is equal to cos of the power, that is n theta, plus iota sin of n theta, right? The power is multiplied with the angle. So this is the de Moivre's theorem, and I'm going to use this theorem in the proof. So let's take a to be equal to cos of alpha plus iota sin of alpha, and taking b to be as cos of beta plus iota sin of beta, and taking c to be as cos of gamma plus iota sin of gamma. If we add all these three, we get cos of alpha plus cos of beta plus cos of gamma plus iota sin of alpha plus sin of beta plus sin of gamma, right? And it is given to us that sum of cos alpha, cos beta, cos gamma is equal to 0 plus iota. It is also given to us that sum of sin alpha, sin beta, sin gamma is equal to 0. So writing here 0. So we get this to be as 0. That means the sum of A, B, C is 0. Let's consider the sum of the reciprocals of A, B and C, right? That is 1 over A plus 1 over B plus 1 over C. We get 1 over A, that is cos of alpha plus iota sin of alpha. Can I write this as cos of alpha plus iota sin of alpha to the power -1? Yes. So 1 over A means cos of alpha plus iota sin of alpha to the power -1 plus 1 over B is cos of beta plus iota sin of beta to the power -1 plus cos of gamma plus iota sin of gamma to the power -1, right? Now I'm going to apply here the de Moivre's theorem, where n is your -1, right? So this becomes cos of n alpha plus iota sin of n alpha, that is cos of negative alpha plus iota sin of negative alpha. So this is equal to cos of minus alpha, right, plus iota sin of minus alpha plus cos of minus beta plus iota sin of minus beta plus cos of minus gamma plus iota sin of minus gamma. Very fine. Okay. So we know that cos of negative alpha is always cos alpha. So writing this as cos alpha. From here also we get this to be as cos of beta, plus from here I can write cos of gamma. Collecting all the terms of cos and plus iota collecting all the terms of sines. Now sine of negative alpha is negative sine of alpha. So taking negative outside as common from all the terms of sines. So this is sine of alpha plus sine of beta plus sine of gamma. And again, because the sum of cos alpha, cos beta, cos gamma is given to be as 0 minus iota, and sum of sine alpha, sine beta, sine gamma is also 0. So this is equal to 0, which means the sum of the reciprocals of A, B, C is equal to 0. Right? Okay. So this implies if I take the LCM, I get A, B, C, and here I get BC plus AC plus AB equal to 0. Or taking ABC to the other side, I get this sum to be equal to 0. Right? Okay. So what is BC? B is cos of beta plus iota sine of beta. Right? And C is cos of gamma plus iota sine of gamma. Very fine. Can I write this as, if I use the Euler's formula that states that e to the power iota theta is equal to cos of theta plus iota sine of theta. This is your Euler's formula. So if I use this over here, I get this thing to be as e to the power iota beta, and this is e to the power iota gamma, which in turn gives us e to the power iota beta plus gamma, right? So writing here for this e to the power iota beta plus gamma, and then plus AC. What is A? It is cos of alpha plus iota sine of alpha, and C is cos of gamma plus iota sine of gamma, plus this AB, that is cos of alpha plus iota sine of alpha, into cos of beta plus iota sine of beta. So similarly, writing this as plus e to the power iota alpha plus gamma, and for this writing this as plus e to the power iota alpha plus beta equal to 0. And yes, this step is also equal to 0. So now again using the Euler's formula and writing this as cos of beta plus gamma plus iota sine of beta plus gamma. So writing this further using the Euler's formula again. So writing this cos of beta plus gamma plus iota sine of beta plus gamma, plus cos of gamma plus alpha plus iota sine of gamma plus alpha, right? Plus cos of alpha plus beta plus iota sine of alpha plus beta. Now this is equal to 0. If I write this 0 as 0 plus iota 0, equating the real parts and the imaginary parts, we get cos of beta plus gamma plus cos of gamma plus alpha plus cos of alpha plus beta is equal to 0. And when we equate the imaginary parts, we get sine of beta plus gamma plus sine of gamma plus alpha plus sine of alpha plus beta is equal to 0. So we have proved these two results, right? Required to prove first and second result also. Now because we found that sum of A, B, C is equal to 0, can I write this as if I use the formula, its square is also equal to 0? Yes. So writing the square for A plus B plus C, that is equal to A square plus B square plus C square plus twice taking 2 common. So it is AB plus BC plus CA equal to 0. From star, we get that this sum is 0. So writing 0 for this. So this implies A square plus B square plus C square is equal to 0. Writing the value for A as cos of alpha plus iota sine of alpha to the power 2 plus cos of beta plus iota sine of beta to the power 2 plus cos of gamma plus iota sine of gamma to the power 2 equal to 0. Now using again the de Moivre's theorem, here I am having n is equal to 2. So first term becomes cos of 2 alpha plus iota sine of 2 alpha. So this implies cos of 2 alpha plus iota sine of 2 alpha, then is cos of 2 beta plus iota sine of 2 beta plus cos of 2 gamma plus iota sine of 2 gamma. This complete sum is equal to 0 using de Moivre's theorem. And then if I write 0 to be as 0 plus iota 0, equating the real parts and the imaginary parts, we get cos of 2 alpha plus cos of 2 beta plus cos of 2 gamma is equal to 0. And when equating the imaginary parts, we get sine of 2 alpha plus sine of 2 beta plus sine of 2 gamma is equal to 0. So we have proved first and second result also, right? So de Moivre's theorem is very helpful in proving such kinds of results. Alright, thank you.